Hello. Yes, Mr. Shah, do you hear me? Thank you very much. So in today's topic, we will be talking about the building information modeling concept with the contemporary applications. And one of the important tables or a way of showing today's topic was like found in one of the Autodesk University's event in 2016, I think. It was Alan. Sorry, it was Bill Allen, one of the presenter who actually presented the topic. I was, here, and I give him a big shout out and thanks for this information. And the overall process of the overall table can show you how the design platforms has been evolved from having ability to draw with a hand drawing, then to the CAD, then the overall it's been discovered that the concept of parametricism has been introduced to the world of parametric architecture or digital architecture. Then we have BIM, and also it's accumulate the time frame and an estimated time frame of the evolution process. By quickly presenting how the hand drawing has been evolved, and I bet all of us have a quick knowledge on that with the humanity trying to draw the first plan on a clay with the Sumerian civilization, and then with the Egyptian to discover the papyrus, which is kind of a very primitive way of using a paper, and then a better paper, of course, will be discovered around the medieval. And you can know that the more or the most sophisticated design platform we have, or the media or the tool we have for the design, the result was more sophisticated, and we get better results with better tools that we have. And recently we're going to get better tools like the one that you can see right here. Although it's kind of a painful and lack accuracy, but it can be considered as a big enhancement if you compare it to the previous set. And recently we have the tracing paper, and I was still using this in my education time, and yet this is the techniques that we have. It's lack of accuracy in most of the time. Fixing issues on error, it was like a painful process, and it wasn't digitized until the second phase, or around the 1960s and 70s, we discovered the computer-aided design. The computer has been enter into the business, and that caused the overall humanity and the engineering field to go toward try to use computer to digitize the overall process of the design work. And in CAD we have the same way we have in drafting. If I want to draw any architectural element, if I want to draw this stairs, that means that I have to draw it in the plan, and then I have to draw it in the section, and then I have to draw it in the elevation. And that's a crucifying, painful process that create lots and data, because you have to repeat your effort for each representation or each view of the object. Yet, indeed, CAD, and I'm talking about the computer-aided design, which is a nature of a design, not AutoCAD itself, has give us a better tools, have given us a way much more accuracy, easier way of fixing error if it's happen, when all of us working in an ink and pen, and like it's kind of very frustrating to fix a small mistake, or to comply with your design instructor who keep changing forever for your design. You're gonna start hating design itself because you have no tools to make quick changes. And this is the issue that we have. And the same concept, the digitization of the hand drawing process that happened in CAD is the problem, that you cannot change and you have to repeat yourself to represent one architectural element. And the second sad part of the CAD, I'm not criticizing CAD, of course, but I'm just giving the pros and cons for it. It wasn't having any kind of a smart relationship between the architectural element. Actually, the architectural element, like a column, it does not recognize itself as a functional entity. It doesn't recognize itself that it has to carry the slab or the beam above and to be, sitting on a foundation and somehow. Meaning, if I want to reduce the height of the slab, the column is just like a dumb, unsmart element that he keep protruding the slab. And I think all of us in a specific level, when we work in a 3D Studio Max, face this annoying issue that if we change the height of an element like a slab, we have to change painfully all of these slabs and all the columns and all the walls related to it. So these are kind of, an annoying issues that we all faced in a CAD, and that calls lots of work. You technically have to passively design or redesign or redraw every line and every point that you need to be done, and it's a kind of a painful loss in time. Lots of softwares have the same technique. 3D Studio Max, for example, have the same issue. It's not only AutoCAD, and I know it's have a kind of specific topics or specific commands that have parametric elements, but in its core, it isn't a BIM application and it's not fully integrated process. So in a CAD design software, you have no smart links, you have no smart link between the element himself in a different view, and no smart link between the element and other elements in the same building, so the columns and the slab and the slab and the foundation and so on. There is no smart links between them. And again, you are just technically drawing arcs and lines that represent each one of them. And the most important thing that even the design, the process of the design is still existed only in your head. So the computer, the CAD doesn't know that the corridor have to be locked on a minimum of a 1.8 meter, for example. It doesn't know that you have to set back in a specific value for your building out from your neighbors. The idea of the design constraints is still in your head, and that's the most important downside that we have in the CAD platform. Thankfully, and the instructor or the boss will ask you to change. And yes, you're gonna say, did you change the slab height? And of course, you have to go and comply with your boss in the work in the company or your instructor in the design. You have to go change the wall height, you have to change the elevation, you have to change the section, you have to change the bill of quantity, and of course you have to send all the changes that you've done in the 3D guy if you have a special guy for rendering, or if you are a sad soul like when all of us been a student in a specific time of our life, you have to redo the 3D all by yourself again. And that can cause lots of fights and headaches because the changing process for the design is a significant, painful process. And of course you have 3D Studio Max to make the presentation, you have plans made up by an AutoCAD file, this section probably by a different file and a different person in a different location in the schedule. Probably you're going to use Excel to do that. And they are unrelated. So whatever document you are issued related to your design CAD project, it's not linked to each other. And you are using thousands and hundreds and tens, for the applications that they are not integrated, and people working in them, you really need to coordinate. You need to pick up the phone and tell the people, hey, for the 3D guy that I changed this section, I changed the room. And any mistranslation, any miscommunication, and trust me, they will cause lots of damage and deficiencies and error in your work. And I don't want to go more detailing with the pros and cons with the CAD, but I think the CAD process is well understood by all of us. These are the two links for more information if you want to, Google that, or just go for the my YouTube channel. I have previous two lectures that detail this process relationship between CAD and BIM, as you can see in these two links. Now, the third issue that I want to demonstrate, or the third step in the evolution of our design tool or our design process, that the humanity discovered something called parametric design. What is parametric design? Is basically that you can, or you, instead of creating a fixed element based on points, like what you do in CAD and Max, you can create architectural elements that basically have dimensions and materials and property defined as variables. So variables can be fed by you automatically, or it can be, manually, or it can be fed automatically by each other, or by a master variable that we call parameter. So the parameter is, just to simplify it, is an important variable in the design process or in the design media that with a one click or the one simple change in it, you can change the entire building or you can change the entire geometry. And he will order the less important variables or less important parameter to take the, the numbers or the value or the text or the material driven by himself. So the parameter is like the boss of all variables. So how that's been happening, that's happened exactly around 80s, and it's more into the design in around mid-90s. The issue is that you can find this concept, and this is the misleading in the design platform, for example, in Rhino or SketchUp, and if we compare it to Autodesk Revit, for example. It can be happened, having a parametric design can happen in a BIM environment platform, like it can happen in Autodesk Revit, for example, and it also can happen in a in a non-BIM platform, or even a CAD platform like Rhinoceros or like SketchUp or 3D Studio Max. The best example or the saddest example you can face is when you try to learn Max for the first time. The first time you open Max, that's kind of a spooky moment, a scary element of your life, because you can see lots of tools in front of you, and the first thing your eyes goes to it, that Autodesk try to make you, not scare away and run away from the software, is the box. So when you create the box, that you're gonna get, length and width and parameter, and when you see the box for the first time, you feel proud of yourself. You don't know what the nightmare lies behind making this box. And the issue is that there is parameters for it. Its length and its width and its height, as you can see in this very basic picture. Does that mean that there is no variables in it? Of course not. There is each point have X, Y, Z values, and they are variables, but they are less important and will be driven by the important variables, which we call them parameter, which is length, width, and height. And when you feed this number with any value you want, they're gonna control the rest of the object, as he's gonna give each point the value of it automatically. So that's why you don't care where those points are, but you care how wide and how high and how much the depth of this element. As an architect, you don't need to care about this minus 0.1 point, comma 0.2. All this information is useless for you. You really need to know the box XYZ. And all of us will exercise the process of changing the height of that object. So one click from 800 to 2000 to 4000, immediate change for the geometry. This is a parametric design, very basic parametric design in a non-BIM platform. So that can be really, really interesting to know. Now, what is BIM actually now? If this is if parametric design can be happen in non-BIM elements or non-BIM platform like Max and SketchUp, what is actually BIM? And I will leave the floor for Mr. Shad to take it from now, and he can start sharing some slides and give you lots of insights relating to this. So Mr. Shad, can you help me?
Yes, just give me a minute and I will start.
Lovely. Yes, excellent. Thank you. Thank you, Mama. Thank you, Mr. Shad, for this great information. And I will build up on what Mr. Shad was. Thank you, Mr. Shad, for your valuable information. I'll just build up after what Mr. Shad is give us from very valuable information that, and mainly to build up the link between the parametric design and the one I explained the first step and the building information modeling. So, and as you saw with Mr. Shad, that we have multiple layers now. So we don't have only the 3D level or the limitation of 2D and 3D, but rather we have 4D, 5D, and it depends on how much parameter each D you have, each dimension you add, is actually, for example, the fourth dimension, which is the time, and the fifth dimension, which is the cost, or the location for the sixth one. It can specify what is actually built from the building at what month. So maybe at the 1st of January in the beginning of your project, you just have the ground floor, and that's the time dimension and the location dimension. And the BIM platform will show you only the ground floor of your building. And maybe after 5-6 months in June or July, the Revit can show you what is the building look like at that phase, and probably it could be at the second or the third floor. And that's how important the building information modeling and it's an application size, because it's allow you also to add more dimension to your work. It depends on how much you want to put as an eye or information in it. We're gonna get, again, as Mr. Shad show you in detail, and a collaboration, fully collaboration between all the people working on the same project. And also, as he show you the example in the window, we have a smart elements, and now the entire building can be generated from the conceptual mass inside Revit to the environment project of Revit in a couple of seconds, and you can make all plans and sections within maximum 60 minutes. And I'm not gonna compare myself. You want to do that geometry in Max, and then you have to slice it with the section tool, and then push the section each 4 meter manually, and then export that to CAD to get your plans, because it doesn't have any typical floor, as you can see, as this geometry. I will not be happy to do this job in AutoCAD and Max, because that can take forever, and its maximum can reach here 60 minutes to do the same geometry if you're gonna use Revit or building information modeling platform. And again, to link it to the parametric design, as I said, that now in building information modeling, because I have a smart building, that each part of it recognizes its function, actually the architectural elements and the structural elements are connected to each other. Now I can get a smart building that if I want, for example, to change the type parameter of the support, as you can see in this example, if I change one value from this specific type to this type, immediately the plans, sections, and elevation will be generated automatically, and all those are linked to each other. And if I choose this option, if I change one parameter, the entire tower will be changed, and the plan, sections, and elevation will be changing immediately. Now, the concept is in BIM, and now if I'm talking about parametric design inside the BIM, now I have only one parameter usually to be changed. If you notice that we change a level height, we change the type of the structure, and then the entire building will be regenerated immediately. That's great, I know, but that doesn't allow an iteration, that doesn't allow an automatic change for more than one value in the same place by a person or by a computer, and it doesn't allow a complex steps of generation. So there is no algorithm. So now for a couple of seconds, you're going to hear math. So there is a math because there is an algorithm, and there is also a complex change in parameter. And of course, all architects really do hate mathematics, because we've been told before we enroll to architecture that it's the only department that doesn't have math. But it's a kind of a sad story, because there is lots of math if you want to get advanced in architecture. So we're going to see that's how that story goes a little bit. So if I look at the rapid change in the design platform, that first we have digital design, which is CAD, and then we have now BIM. It's also digital, and it's also depend on CAD. It's evolved from CAD, but it's a little bit more specific and can provide us a higher level of design platform. This slide will keep updating itself as we go throughout the lecture. Now, the next phase we have is computational design or algorithmic design. It's the whole idea came by the French science Simon, and I think in 2008 he put the first time what's called computational thinking. So what is computational thinking is just basically algorithm. So you know your problem, and you really need to divide the problem into smaller pieces, solve the pieces, and then teach the computer how to solve this problem by itself. So that's kind of a revolutionary process. This is discovered that when he was trying to make a special teaching aid design, and then this concept goes quickly to the architecture and design field to give us the CD or the computational design platform. So what is computational design? Computational design is mainly the ability to have it's a design method that allow you to create single or multiple design options that actually harness or use the power of computer to design. And that means you are teaching the computer how to design. How? Of course, by giving it an algorithm or a logical steps connected to each other. And in order to do that, you also need a visual or a textual programming language. So those lamps you see now, all of them are one object, are one algorithm. And the resulted geometries is actually the options you can get automatically if you press a couple of buttons here in the computational design platform. And yes, this can be exist inside BIM, and yes, it can be existed in Revit, for example. And we can generate hundreds and thousands of building possibilities and options instead of having only one. And that's the power, because you have to teach the computer how to design, and that isn't a complex process. And I just put in this slide some of the characteristics of the computational design. It's basically the computer, of course. It can create one or more. So now the parameters that we talked in the previous phase, the parametric design, usually one parameter. Here we have multiple parameters to check and to test. It allows the repetition, and it can detect the design pattern. So it knows what you are sketching. You can teach that to the computer. And you really need to have some knowledge in textual or visual programming. Now back to our fear scale. Now, of course, if we put that in an algorithm or a formula, if you put an architect plus math plus programming, that's an important thing, because it's going to cause fear and terror. Lots of panic will happen. Lots of architects, reject those two concepts, yet they are really, really easy if you spend some time looking at them. So what is algorithm? We keep saying we have to teach the computer and we have to provide algorithm. Probably ladies here in the hall are more familiar and using algorithm more than anyone else, because if you want to make a cake, so you have to really need a special recipe that you have to take it from an elder lady, or you have to steal it from the internet, and it's gonna give you the details. It's gonna give you the amounts of flour you have to add, and the amount of sugar you have to add, how to mix them, how much water you have to add, if you need to let that in the oven, and how long you have to keep it in the oven. All these logical steps that can, and I hope that it will end up in a good cake result like this one, is algorithm. So you put in a piece of paper, or your mother, maybe she put in a piece of paper the steps, the logical step with the component required to create something. This is algorithm. And in computational design, an exact system has been used. And the example they see right here is taken from a design pattern book, in one of the most important book in the computational design. It's a recursion system. And in the recursion system, you're going to make very basic concept. You're going to have a square, and you're going to tell the computer to make a copy of the square and scale the square down in both x and y with a specific value. Then you're going to ask the computer to scale it down as if you are working in Max or AutoCAD, but you are recording these steps, And then you're going to tell Revit or computational design platform like Dynamo, for example, that I need to repeat this step 5 times. And the result is that the shapes will be repeating. So if I is 1, this is the shape. If I is 5, the computer will repeat this process 5 times. If it's 12, it will get this shape. And by that, you have the ability to design the design process. You are not designing the end process. You don't have a specific shape in your head, but you can design the process of design to the computer, and you're gonna have with endless possibilities of forms or functions that reflected back from this design shape. And how many programming tools we have? We have basically 2 types. We have the visual programming, which is super easy, and we have the textual programming, and they are both here for Autodesk Dynamo, of course, inside Revit. So another example, if I have to have this box and I want to end up by this sketch, you can program this step. You can tell the computer to cut this small piece in the lower part, and then to go up to the top part, cut it, and then displace it or move it, and then divide it into smaller pieces. And then the computer can repeat this process into other shapes with other possibilities of dimension, creating almost an infinite amount of results. Now, how that can be done in a BIM platform, how I can apply the computational design in a BIM platform, and what happened if I applied it in a non-BIM platform. So one of the famous examples that I see with the Snowflake Tower project, it's for a very important office called UN Studio. It's a European office, and they submitted the project, the tower, to Abu Dhabi, and they used Rhinoceros. It's a non-BIM platform, and they was just designing this shape, of course. That's let me show you the end-up result. That's the end-up result of the tower. And what they want to do is basically they design 3 circle or 4 circle, actually 3 circle in this direction, and 3 smaller circle on the other direction of the rotation of 360, and they define their distance in a polar system with their radius as parameter. And this is the node-based design. This is the visual programming. And you can change the depth, width, and height, or whatever value you have. These are the parameters you change. And you can get this shape. So if you change the values, you can get this shape. The shapes you get is literally limitless, like thousands or hundreds of thousands of plan shapes. And whatever they pick, whatever they see is suitable or nice, they just accumulate it in a specific height of the plan, and then let the computer morph or generate the overall shape of the tower. The funny business is when they finish the shape and they like the shape, they have to send it, they show it to the client. Of course, the client accepts the shape and tell them to give them the full documentation for the tower. How many panels they have and what's the specification of the panel, so they can send it to the robotic and the manufacturer so they can build it. And of course, it's not possible in Grasshopper, neither in Rhinoceros. So they have to send it to Revit, and they redo the entire work again. And that's what we spoke several times. There is a waste, a data waste. They lost money, they lost time, they lost significant amount of data just because they are not using an interoperable tool. They are using a wrong platform. They have to go Revit. They went to Revit, they make it again, and they lost a significant amount of time and money on it. And when Mr. Tobias, the designer, he came to Ajman University, and I showed him this exact same tower that he did, but this time all made in one place, which is Dynamo and Revit. And he was, really happy to see that there is, that there is a shape, and you don't need to send the information from one software to another, and the panel is existed, as you can see in this side, and even the plans and section and documentation is ready for you on the same platform. This is the exact important interoperable option of work, a method of work, because of the use of a computational design tool inside a BIM environment. Go use it, do that in the 3D Studio Max, do that in SketchUp, do that in Rhino, and eventually when you go to the bill of quantity, the cladding, the exact modeling of or detailing of the object, eventually you have to go to AutoCAD, and for a specific shape, it's almost impossible to be done in AutoCAD. You have to go back, redo all the work again, lose all the time again, and pay money for it to redo it in Revit. And that is a very bad process of design. And I have prepared for you some comparison between the two methods. and literally with the CD, the computational design, if you done it inside the BIM, there is almost no waste and no need actually to use any interoperability tools. It's fully integrated because you are using one platform, and this is the right way to practice architecture for the time being. And again, to monitor and to link each other, link ourselves to the previous work, we have our digital architecture and the CAD era, then we enter to the BIM era, and then now we are in the computational or algorithmic design. And as I draw the shape is overlapping with BIM because yes, it could be possibly happen in a digital or a CAD application like SketchUp or Rhino, not only compulsory to be done inside BIM. Now, the next phase happen in the design, architectural design phase is the generative design. And with generative design now we can use cloud-based server. Now we can use the genius supercomputers available in the cloud. We push our computational design work. We give them the work we've done in the computational design, and the computer will generate us the design for us. So if you have a look at this shape here, you will understand what I'm saying. It's not me who is designed this. It's the computer and the cloud base or the algorithm that we can use, generate all the options, if you see this, and it's move the furniture and increase their amount based on the change in the X and Y of the building. And this is the new generation. Again, that's the next phase that happened. And that solution will be pushed back to you as a designer, and you will be picking which of those are suitable. You don't really constrain yourself with one design option. And that's another example done by, available on Autodesk main website to demonstrate the generative design process for designing an office, for example. Have a look. It's, you wanna waste time and make all those design options? You can't. You need, let's say, if you are a good designer, you have a staff, you're gonna make, let's say, one design proposal, one snapshot of those. And the analysis of it, you can do it maybe after you finish the design, and you may be spending weeks to make one design option. With generative design platform, no, he's gonna generate for you the plan, analyze the plan, best things, pros and cons, compare them to each other, and then set the result back to you to tell you which is the best design option to choose. You can't do that, mate. You're gonna need months, and you're gonna need years in order to do the similar process. Project to Fractal is available now, I think, and also Project Refinery. Both of them are Autodesk. I think they are free for educational license. So if you are a student, you can go ahead and try them. You can upload your Dynamo work to them, and you can see the possibilities of the shapes, for example, you can have. And this is another example of having generative design work. It's a stadium in China, and you can find this example on my channel in YouTube. And you can look here, have a look at this part. There are, I can't read. It's a 14 million design option. Yes, I'll repeat that, 14 million proposal. And you can go ahead and look through that. You design the algorithm behind this, and then the computer will come change the head, the amount of heads, the location, the heights, and you can see here how many design options we have. And when you are happy with, let me just slide that back, I think, And you can see when the designer scroll down, you see the design option. There is long list of that. You can find the stadium shape here. You don't need to supply your client with one shape. You can provide 10 shape, 100 shape, 1,000 shape. It's up to you. Or if you are really good at it, you can compare and analyze which one is good and why. Benefit, cost benefit, cost-wise, thermal-wise, I don't know, CO2-wise, and then submit the best of the design after you do hundreds of analyzing, which can take a couple of hours instead of a couple of years to do this job. And whenever you are happy with the result, you can just send that back from the cloud system to Dynamo and then to Revit, and Revit will automatically generate the building for you. And this is the beauty of generative design. That's what I'm trying to tell you, or that's what's the actual current condition of work that we have, a smart or artificial intelligent BIM. And that's what really, that's the real hotspot of the design here in the architectural field, and that how you can use the artificial intelligence inside the building information modeling. And again, for more information about those two topics, the computational design and generative design, you can refer for those two previous lectures. This lecture was also a lecture prepared and with the cooperation with Tishk University. And now we have a digital platform, and then BIM, we evolved to BIM, one parameter to change, then evolved with computational design, more than one parameter to change. Then we jump to generative design, where is the cloud and the computer are actually smart enough to choose and design for us. So we're going to have now an artificial intelligent BIM. And basically, the BIM will self, if you reach an artificial intelligence, have its interoperability. So you don't need to waste time and effort if you work in a BIM. And the red path, for example, show what we are all as an architect suffer from when we work in the traditional CAD system. So we have our information, the program push, where you have information as an Excel file, and then you go to AutoCAD to make your schematic, and then you have to remember the numbers and manually feed them into a zoning, and then the zoning, you lose half of it, sorry, the bubble, you lose half of it to make the zoning, and then you lose most of the zoning to make the plan, all this waste, all this repetition inside AutoCAD, and then when you make a plan, the client agree on it, you go to the schematic. Probably you're not going to use Revit, you're going to use Grasshopper, for example. And even if you use Max, you're going to take the plan and send it to 3D Studio Max to design the form. You make the elevation and the 3D geometry in Max. And guess what? If the client say yes, you have to go to AutoCAD again and draw the elevations. And that's another significant drop in the data, because there is a loss and there is repetition. But if you use a BIM tool, that's not going to happen. Not even the Excel information will be lost. You're going to make the 3D, the elevation is ready. You're going to make the plan and zoning, the information will not going to be lost. The overall push from a design presentation to schematic to construction documentation will be in the same time, so there will be no loss of information on wherever. Lots of example I have. I don't want to take too long with speaking about the subject. I think the concept is clear. For example, working in Grasshopper and then sending the work to Revit, you're going to need an interoperability tool called Hummingbird, or you just make it inside Dynamo and Autodesk, and you don't need to go jumping from one software to another. Now, BIM isn't about the new modern building, but also it's go back to deal with historical and heritage building in a concept called HBIM. And in HBIM, simply you can use an UAV or drone or any kind of a 3D scanner you can use a 3D scanning or a photogrammetry tool to make a 3D image made of usually points or photons image that you can drive or create from it a BIM model. So you get your image. This is the 3D image. It's not a BIM inside Revit. You import it, and then you scale it properly to the scale, and eventually you can create a Revit model out of it. And this is, for a research, this is one of the hottest topic also, because you can teach the computer how to construct this traditional building or cover up the demolished part of the heritage building, and make Revit can create it for you. Specifically, if you are able enough to use computational design or the smart tool inside Revit to design for you the missing document, or sorry, the missing detail of the traditional building. This is also an important part to work on. So the interoperability can actually, with the BIM, are actually kind of bridging lots of missing information and can give us an extra layer of detailing here. The last thing happened, which is a slightly might goes out of the BIM itself, we have robotic. So now we have a smart building. Each part of the building know its location. It has a time, it has a cost, it has money. So now I can attach a smart element to it, which is a robot who knows where to sit, he knows where to do work, and he knows what to do. So the basic robotic concept that depended on the BIM application is the 3D printing. And this image for the Sheikh Mohammed bin Rashid is opening the first 3D house printed here in Dubai. And it's completely done by a 3D printer, a huge 3D printer that can actually print the entire house, as you can see. Robotic have a very powerful application in the construction field. It can lay bricks, it can demolish part of the building, it can render, it can lay glass brick, and it can even join the reinforcement bar. You don't need to use manpower for that anymore. It can clad in a specific location, especially if the environment was harsh, that the human being cannot work, and it's super fast because, you know, now that's also related, or it's actually related to BIM itself, because the robot knows the location of the components, knows the time that he have to put it on and where to put each element. This wouldn't be available if he is not actually recognize its location and the location of the element and the function of it. And lots of other applications for the robotic is printing chairs. And I saw this one in I think in Dubai. They are just in Design Week festival, and they just take the plastic bag and all the plastic waste, they melt it down and make furniture of it. It was really awesome. And now it's been applied with a part of the Mars campaign, because it's actually can melt sand and create houses. And they are packing the shuttle that they want to send to Mars with these equipment, so they can actually build homes there out of the sand material available there in the planet. So now we have BIM, and because of that, we have a robotic. And the last topic to talk about is the IoT, or the Internet of Things. Now, because we have a smart building, we have a robot that can have enough knowledge to know its location and time, and he knows, or it knows, its function. What if we can make a group of robots that work on the same task? Those robots will clash with each other, they hit each other, or they're gonna damage each other because they are not recognizing the location and the function and the timing for each one of them and the job that have to do. But with the Internet of Things and, you know, the enhancement that happened in the internet, the 5G mainly allowed the robot to communicate between each other. And this created a network of smart elements, not only robots, that can help each other to create the building or create a specific job. The architectural and the construction application of that is significantly important. You can have an elevation facade that automatically interacts with you, and it reflects what you see and enhance the image. It can create pleasure and create, you know, like more interactive environment and friendly environment to the passenger around by. You can create an operable lighting fixture floating wherever you go to provide you the light or music. You can create smart building. One of the best example to represent that is an Apple Park, which designed by Foster and Partner. The building is, you know, fully integrated and have a very smart building that can control the amount and measure the amount of the CO2, sense the temperature outside and control the temperature for the inside, because as the same technique applied with a huge building is the same technique applied with a small smart house. All the cameras, all the heating system, or the security system, doors, windows are operable, and they are a smart element linked to each other. So if an elder person, for example, with his watch, having a heart problem or a health issue, the building can sense his heart rate and immediately report to the hospital. It can control the security conditions. So if a thief tries to get into the house, it can isolate the residents in one location and call the police. It controls the doors. It's literally can communicate between each other and provide the best of the service for the user. Other example, which is the same previous example, but this time not a robot. They are having drones, and there is more than one drone that can work with each other to construct the building, and they are not going to clash with each other because each knows the location and the time and the function that he does. And there will be like hundreds and thousands now of them is operating to create artistic work, and they are actually also can be applied to build a building or actually spray the concrete on a similar or such constructional system. So the last thing is that we find ourselves that we start up with a very primitive or very basic way of design. We end up with the IoT now, and we have a way and much more enhanced tools to work and to enhance the construction and design process. And all that is just a quick introduction and a quick background knowledge for you, so you can know what BIM is actually can implies and where it can be used. Thank you very much for your time, and sorry if I talk too much, and I wish that you get benefit of it. If there is any question, I'm more than happy to answer. Thank you, dear. Thank you very much, and have a lovely day. Thank you very much. Thank you.